So welcome to Dynamic Foundry Group small video section. Today we are going to see a video on importance of effective nucleation in ductile and gray cast iron. Why? What is the role of nucleation? Improve machinability, give dimensional accuracy and consistency, good nodal count, better nodality, desired matrix in microstructure, required physical properties. Here you can see three pictures where in first picture you are seeing good nucleated metal with 400 by 15 grade that is fully ferritic. Nodal count is very good. In the middle picture you can see nucleation is moderate. You can get nodal count in a moderate way, but there is a still scope of improvement. In the last picture, you can see poorly nucleated metal where the nodal count is very less. So you can see here there is lot of scope to improve the nucleation level in the metal. If such kind of low nucleated metal is there, the chances of getting poor machinability, inaccurate dimensions, improper matrix, and not achieving physical properties and microstructure in the metal are more. So nucleation plays an important role to get consistent quality of metal. Let us understand possible causes for poor nucleated metal. Inoculation size. You have to define that size based on your ladle size and metal treatment size. Inoculation quantity and percentage. Inoculation process, inoculation fading time, oxidized inoculation, chemistry, pouring time. Why inoculation is important? Inoculation plays an important role in nucleation of casting. In gray cast iron, chill depth is get reduced due to nucleation. Similarly, in ductile iron, after inoculation, nucleation effects helps in improving machinability, improving nodal count, and this helps in reducing shrinkage defect. Proper inoculation helps in achieving desired microstructure, matrix, and physical properties. Types of inoculation. Primary inoculation, when metal is taken from furnace to treatment ladle or pouring ladle in case of cast iron. Secondary inoculation, inoculation added in the ladle when metal is transferred from the treatment ladle to pouring ladle. Stream inoculation is one which is done in mold stream. Mold inoculation is one which is kept in runner bar of the mold. Many times, multiple layer of inoculation will help you in getting better nucleation effect in the metal. Late inoculation will always help you to have more nucleation and more nodal count, more ferritic structure, and better machinability. Hence, people does stream inoculation to improve nucleation level in ductile iron. Process control in inoculation. Inoculation type, ferrosilicon base, strontium base, barium base, or any special inoculation you can use for the inoculation purpose. Size of inoculation, not too small, not too large, based on your ladle size and pouring treatment size as well. Quantity or percentage of inoculation. Quantity of percent of inoculation is depending on your metal weight. So metal weight is important. Inoculation must be added in the metal stream. Inoculation must be started to add once 15 to 20% metal is added in the ladle and finish it when 85% of metal is poured in ladle. It is important to understand why percentage of inoculation or inoculation weight is important. Let us say an example here. We are taking 0.4% of inoculation and where our bunch weight is 45 kg. So one ladle is taking 6 boxes. So his weight will be 6 into 45, that is 270 plus 10 kg additional metal he is taking for safety. So 280 kg metal will be carried out in the first ladle. In the second ladle, 5 boxes he will pour. So his weight will be 5 into 45 plus 10 kg will be 235 kg. So now let us take the difference inoculation for both. Ladle 1 with 280 kg metal has to have 280 into 0.4, that is 1.12 kg of inoculation, while ladle 2 with 235 kg of metal will have 235 into zero point 0.4, that is 0.94, that is 940 grams of inoculation. If we take 250 into zero point 0.4, that is 1 kg of inoculation as a standard and do it, then for the first ladle, inoculation will be less, and for the second ladle, inoculation will be more. So to avoid it, one has to take exact weight of inoculation based on the metal they are planned to take in the ladle. Inoculation is effective till 6 to 7 minutes max. So fading time of inoculation is very important. You have to finish your pouring before that stipulated time. After that time, effect of inoculation gets reduced and the metal poured after that will be having less nucleation, which may cause you less nodal count, poor machinability, thus dimensional inaccuracy in machining and shrinkage issues. So pouring metal within given time is important and will help you to get good quality of metal. Pour nucleation micro. Pour nucleation micro shows less nodal count. Nodal count will give rise to more pearlitic and thus give you poor machinability issues. Poor nucleation is mainly due to less inoculation added in the metal, improper way of adding inoculation not added in the stream, and variation in inoculation size also. The reasons: poor inoculation practice, poor inoculation size, late pouring, less inoculation added, more metal for treatment or pouring, high pouring temperature, oxidized inoculation. You can see here some good practices to be followed for better nucleation and to get good consistent quality of metal, that is 100% payment of metal, to ensure your inoculation percentage is correct. Pouring control with help of timer will help you in controlling your inoculation fading time. इनॉक्युलेशन नेहमी मेटलच्या धारेवर टाकावे. साधारण 20% मेटल टॅपिंग झाल्यावर इनॉक्युलेशन टाकणं चालू करणे व 80% मेटल टॅपिंग होईपर्यंत इनॉक्युलेशन टाकून संपवणे. Do inoculation in the metal stream. This is very important. How to do inoculation? You have to add the inoculation in the metal stream, and it should start after around 15 to 20% metal is tapped and finish when about 80 to 85% metal is tapped. Avoid oxidation of inoculation and other alloys. You have to keep all these alloys and inoculation in the properly packed trays or in properly packed gunny bags so that your alloys will not get oxidized. Use electronic weighment scale for alloying these elements, especially inoculation and alloys, to get accurate weighment. Now we go to cast iron nucleation effect. Similarly, in gray cast iron, nucleation of metal plays an important role to get good machinability, to get good desired A-type microstructure, to get good consistent quality to avoid shrinkage issues. Here, chill and wedge can guide you for the nucleation effect by seeing before and after inoculation wedge, where you can see the reduced chill. Why chill or wastage is important? Wedge and chill test is a quantitative test for checking nucleation in the metal before pouring. We can also use it as a preventive method to judge metallurgy. Wedge and chill is used for inspection of metal to identify good grade of casting, improve machinability, and to see effect of inoculation after pouring. So you can see in the picture before and after pouring wedges or chill for your reference. The chill depth has been reduced drastically after the inoculation, that is, your metal is properly nucleated. This is another picture. You can see the chilling tendency is reduced. Importance of nucleation in gray cast iron. To get desired A-type microstructure, it is important to add adequate inoculation in the metal stream. Inoculation plays an important role in getting good nucleation and thus good machinability, desired microstructure, and thus meet physical properties as well. You can see here A-type microstructure, B-type microstructure, C, D, and E-type microstructure. So we normally prefer to have A-type microstructure where random flakes graphite in a uniform distribution are most desirable. And to get this A-type microstructure, your inoculation practice and inoculation practice will play an important role. So this is from my side. Thank you very much for patient hearing, and kindly subscribe the Dynamic Foundry Group channel and press bell icon button to get instant notification for new videos. Thank you.